EC&M Asks is a video series that enlists the technical expertise of our brand's subject matter experts to answer our readers' most pressing electrical questions. Posted twice per month, these quick videos present Q&As on topics related to various installations, applications, and troubleshooting scenarios. When our readers ask, EC&M answers. Here's Ron Widup with Shermco Industries, who is also a member of NETA's Standards Review Council.
Hello and welcome to this edition of EC&M Asks. We've got a great topic this time. We're going to talk about the infrastructure inside your power system, the blood vessels, the nervous system, all of that, if you will. It's your medium voltage power cables. For this one, we got a great question from Dylan in Fort Worth, who asked, hey, there are a ton of different options when it comes to shielded medium voltage cable testing and maintenance. We have both 15 kV and 35 kV cables. What methodology should I use to get the most effective results? So Dylan, when it comes to power cable construction and operation, there's so many factors that determine what it is you should do in the field, what voltages you should apply to it, and what can be potentially a destructive test and what is a non-destructive test. And importantly also, you want to get data that you can really use to determine the serviceability or the continued life of that cable. And so where do you go for those answers? Well, I can tell you where we go, and that is to the NETA Maintenance Testing Standard. We go to section 7.3.3. And that section in particular gives you a lot of guidance and a lot of education on what you need to do for your medium voltage shielded power cables. You know, as a member of the Standards Review Council, we spend a lot of time and effort to determine what is the best guide when it comes to medium voltage cable maintenance. And we do that through the consensus process. And additionally, if you need it, there's the IEEE 400 series that has cable testing guidance as well. So you've done all that, you've got questions you need to answer, you've got decisions you need to make, and so who better to do that than the cable guy?
I have this friend, and he gave his cable guy $50, and then he got all the movie channels for free.
You mean illegal cable?
Yeah.
What you have just done is illegal. And in this state, if convicted, you could be fined up to $5,000 or spend 6 months in a correctional facility.
And okay, so it's not that guy. It's actually a friend and a colleague, a NETA colleague of mine, Chasen from Hampton Electric. Yeah, hey, thanks, Chasen, for joining us here today. Really appreciate it. And so you heard the question, and so what would you say to Dylan?
We get this question a lot, and I appreciate the keywords in there, most effective. There's a lot of options when it comes to testing medium voltage cable, and largely they pertain to testing the bulk dielectric of the cable and accessories. You know, NETA does have a really good front end for visual mechanical inspections and the pre-tests, the electrical tests that Ron talked about before. But kind of what a lot of people get hung up on is that testing of the main insulation system. There are a lot of options, whether it be DC, AC, VLF, damped AC, partial discharge, tan delta, dielectric spectroscopy. There's a lot out there, and it can be confusing. NETA's done a really great job of putting together recommended practices for the maintenance testing of cables, especially what would be the average cable, you'd say. The, typical medium voltage industrial cable can benefit greatly from just a simple withstand test. A withstand test being those where, as it sounds, does the cable withstand an elevated voltage for a specified amount of time?
Hey, Chasen, if I can jump in here. Now, remember, he said he had 15 kV and 35 kV cables. Is that what we're talking about here?
Mostly what we're talking about here is medium voltage shielded cables. So anywhere from, 2.4 kV all the way up to 69 kV. That's the typical cables we're talking about in an industrial environment. So what we're trying to do when we go to perform maintenance or testing on that main insulation system is trying to find those weak spots. And withstand testing is one of the easiest ways to do that. It's the most cost effective, I would say. The next better test, if you will, more involved, is a monitored withstand test. So as it kind of sounds, you're doing a withstand test, but you're monitoring something during the test. Typically, that's a cable characteristic. A lot of times we'll be looking at the tan delta value or the partial discharge response during that withstand test and seeing how it's trending during the test. Those can really provide a lot of insight into if a cable is starting to go towards failure, and we can interrupt it before it gets there. Outside of the withstand testing, you have those diagnostic type tests, whether that be tan delta or partial discharge being the two most prevalent. With all of those diagnostic and withstand testing, there's various types of voltage sources that you can use for it, whether it be DC, AC, whether that AC is near power frequency or online, along with very low frequency VLF or damped AC, where you have just a short period where it hits near power frequency. Any of those can kind of be utilized, and each has their pros and cons. It's very difficult, I would say, for the casual observer to pick a test right out of the hat. And each one has their own unique benefits that would really, if you're looking for the greatest return on your investment, it would behoove you to reach out to kind of a qualified electrical testing company or a engineering firm that specializes in medium voltage cable testing.
So Chasen, here at Shermco, we do a ton of cable testing, and most of that is VLF tan delta cable testing. We also do some partial discharge and all that. Would you say that's the most common thing that's out there?
I would say that when you look at the NETA standards, they're written to specifically look at kind of the industry standard, which very low frequency is probably your best bang for your buck when it comes to testing these. DC was the rage and the standard, years ago, and it's fallen out of vogue for some degree. And VLF is that sweet spot of providing enough value for the test while also not being too cumbersome to operate. The way that I try and approach a lot of these medium voltage testing questions from companies is looking at what are your needs. Testing a 5 kV 20-foot run, single phase going to a parking lot lighting. You don't want to spend an hour offline 60 hertz partial discharge test on it. The amount of time that it takes and effort to do that test is probably more than the cable is worth. If you look at another example of, the backbone medium voltage incoming feeder for a critical data center, that one you may spend a lot extra time on and verify that it is performing under very harsh conditions, because that'll tell you if it'll last another 3, 4, 5 years until your next maintenance cycle.
Hey, Chasen, I'm sitting here watching you, and again, thanks for joining us today. But behind you, it looks like a piece of cable. What is that behind you there?
This was one of the cables we took off a job just not too long ago. So 69 kV aluminum, 1500 kc mil cable, quite a behemoth. But yeah, we had that as part of our testing routine to verify that cable operated as expected. One of the various cables out there, they come in all shapes and sizes, and definitely the bigger you get, the more expensive they typically get. So the more testing that we recommend performing on them.
That's a pretty cool piece of cable there. Thanks, Chasen. I was wondering what that was. But anyway, so let's get back to it. So that cable probably had a pretty high reliability requirement. I know one of the things that we did this time in this edition of the new MTS is that we added Appendix D, which gives us some guidance on the reliability requirements versus cable tests that you should perform. Can you tell us a little bit about that Appendix D?
So Appendix D is the guidance for circuit reliability considerations for medium and high voltage cable methods of test. We recognize at NETA that there are a lot of testing organizations or engineering firms that are well versed in cable testing, but may not know all the intricacies that come to it. And so if they want to do it yourself sort of situation, there's Appendix D to give a little bit of guidance on what types of cables we'd recommend and what tests we'd recommend for those types of cables based upon criticality of circuits. So we break it down into low, medium, and high criticalities. We further break it out in a cable type. So, how you'd treat a medium voltage tape shielded cable would be different from how you'd treat a concentric neutral or potentially a oil impregnated, a PILC cable. So each of those have their nuances, if you will, when it comes to what type of tests would best work on those cables. And so there is a little bit of guidance that's given in the NETA Appendix D, and that's a brand new appendix. So if you don't have the latest MTS 2023, then that will be something that you're going to want to pick up to look at that new guidance.
Thinking about Dylan's question and going back a little bit, and so why should somebody, spend the time and effort to look at their power system cables? Why should we do that?
That's a great question. We get a lot of customers asking us, what is the benefit of doing this testing? A lot of cables, you look at them, you set it and you forget it. They don't move. They don't really have a lot of obvious cable failure mechanisms. So why would we need to go do maintenance on it? And I come up with a great example of it is if you are worried about your cable at all, if there is any point in your production that if you lose that cable, it will create issues for your organization. If you think about your peak production time, if you think about that time where it's in the middle of the night and it is just going to create chaos, that is the time that you really need to think about when you go into performing maintenance on your electrical equipment. And cables are not an exception to that you really need to make sure that those cables are going to last you through those peak production times. They're going to last you during those times that you really need them. And if they're not going to last during that time, you need to know that ahead of time so you can either repair them on the spot before you get into that peak production time, or you can schedule to get them replaced if they're still operable during that time.
Hey, Chasen, thanks again for your time today. I know you got to get out on a job site. You're probably going to talk to that plant manager about what keeps him up at night. I'm sure it's medium voltage power cables, and so we'll educate them all. Hopefully you guys got a little education today as well, and we'll see you next time on EC&M Asks.